training the regression random forestry and the what is that? The gradient boosted machine, or almost same. When it comes to data pre-processing, okay, you don't have to do any data pre-processing. Too much of see that doesn't mean right. You don't have to create a training and test data set. Even in the case of random forest or gradient boosted, you need to split the data as a training and test data set. And with the training data set only, we are going to train the model. But here we don't have to convert the text data or the categorical column into numerical column. And also, in the case of outliers, we don't have to do anything. Data imputation, in the case of in the missing values, you don't have to do anything, okay? So next one is the gradient boosting machine, right? Even this gradient boosting machine is also called as an ensemble technique. You can solve both regression as well as the classification problem like random forest. The gradient boosting machine is a very popular machine learning algorithm. Okay, so like random forest, even GBM, I'll just write it here. Okay, GBM, gradient boosting machine. Okay. Okay, so it is even the GBM is also an ensembling technique, or ensemble technique. Okay, in this case, what happens? It creates the base learner first. It creates the decision tree. It's something like, I'll just give you a simple analogy so that with that you will be able to understand how this algorithm works in a very simple manner. First, it builds a base learner. Okay, listen, this is your base learner. It is also called as a weak learner. Even in this case, you create a training and test data set. With the training data set, let's say you train a model. Not we, let's say when we train a gradient boosted machine, right? It starts with the initial model, okay, base learner. That is called, the initial model is called base learner or weak learner. Okay, and then iteratively it will train the model. Next, what it does is it sequentially builds trees. And at each iteration, a new tree is trained to correct the errors of the combined example so far. Okay. So here the simple analysis, for example, you are developing a mobile app. Okay, you are developing a mobile app. In your mobile app, you developed it, but a lot of there are some bugs are there. Right? Some bugs are. It is not generating the OTP properly, or when I do the QTP scanning, right? Scanning is not detected properly, and the price is not calculated correctly, or the total sales amount is not calculated correctly. There are some bugs are there. So what you do is you create a base app, basic simple app. Okay, instead of saying customers, hey, I don't have an app, you create some app, but that has some bugs in it. What you do is, because of time constraint, you cannot fix it, and you take another developer. Okay, you hire another developer, or you recruit another developer, app developer. You ask him to fix that bugs, whatever were there in your app. A new guy, right? So another guy will first you create a the base app, basic mobile app, and whatever the bugs are there, another guy, you hire another guy. It is his responsibility to fix the bugs of this one. The same way gradient gradient boosting algorithm works. So it builds the trees sequentially. Unlike random forest, it does not build the trees. Even in the case of GBM, gradient boosting machine, it creates multiple trees, but it doesn't create all the trees simultaneously or parallelly. Instead, it creates the trees one after the other, or sequentially. First, this one creates this one, and then in case of any errors in this one, to fix that, another tree is built. Okay. So what in this, right? So in this case, iterative training is happening. First, this tree is trained, and then another tree is trained. This tree is built to address the misclassification done by this tree. For example, let's you have 5 customers, 1, 2, 3, 4, 5 customers. For him, it assigned yes, approve the loan, and then he says no, no, and no, right? So the actual is yes, 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 yes only, but your model wrongly classified as no. So what it does is it takes this wrongly classified NN along with that the other customer data also, and then it tries to address this misclassification. It will try to predict or it will try to predict the correct label for this wrongly classified labels. Okay. And then it uses something grading boosting algorithm technique, using which it will try to reduce the cost. Okay. Similarly, what happens, right? Even this tree also, let's say this is a tree 1, tree 2. So there could be in an attempt to address this misclassification, this tree may reassign the classification. Sometimes even this tree, right? What will happen is while classifying it correctly, for example, customer 3, 4, 5, maybe now it assigns YY correctly. So this is actual, this is your predicted. Okay. But 3, 4, 5 now it correctly classified yes. But while doing it for one customer 1 and 2, it makes a mistake of N here. Or let's Y here, and one customer it wrongly classified. Okay, whatever the labels correctly assigned for customer 1 and 2, it did some misclassification. Okay, but only one customer, let's assume that, okay, hypothetically, right, it wrongly classified, but rest of the customers it assigned correctly. But still, there is an issue here, right? To solve this, another tree will come into picture. It will create another tree. Iterated will train. So this tree will pick up this. So in this case, only the misclassification, only one it goes, and then it takes another customer data also. It will try to address this one. So that is how it keeps build these trees, multiple trees, one after the other to fix the initial trees or the predecessor trees bugs, okay, or the misclassifications. The same is applicable for regression problem also. In the case of regression, the values will be there, right? Predicted price will be there. The error is too high. What will happen is it will take those records. The actual and predicted values are too far, right? Let's say if the predicted values more than your actual price, or less than, or very less than your actual price. What will happen is the subsequent trees will try to address that issues. And finally, it groups all the trees, okay? All the trees, and then it goes by the, and then finally it addresses, it groups all the trees, weak learners thing. For example, this guy is no, and he is trying to classify that. This guy maybe, right, the first person is no and YY. And finally, with the combination of all the trees, it will tell, hey, this is the correct one. Yes, 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 yes. All the 5 customers are potential customers. You approve the loan for those customers. Okay, fine. So now I just, this is how the gradient boosted machine works. And I'll just show you how to implement them in